let's talk about the components of a 3D print. So first we have infill. Now take a look at these graphics that you see here on screen. Infill is the internal support that helps the 3D object hold its shape. And so infill is adjusted by density. So a denser infill is going to create a stronger object. So really, you need to just do some experimentation. And this is really where the trial and error piece of 3D printing becomes so very useful in the classroom. You'll see on that picture that there are some infill patterns that are rectilinear. There are some infill patterns that are gyroid. There are some infill patterns that are honeycomb shaped. And so some infill patterns do better with geometric objects. Some infill patterns do better with sculptural objects. And sometimes if your object doesn't need a lot of strength and support, you don't need to have a very dense infill, because you need to remember that the 3D printing process takes a lot of time. A print of any size can take multiple hours. Just to give you some perspective, a print of this size is about a 70-hour continuous print. So the printing process can definitely take some time. And the thing that you need to remember is that if you have a denser infill, that's going to require more material, that's going to require more time. Those are things you want to consider when you're designing and when you're slicing those objects about print time and print quality. Okay, so let's move on next to layers. Layers are the slices, so to speak, of your printed object. So thinner layers mean more detail. Thicker layers mean less detail, but the thing you need to remember is thinner layers require much more time, where thicker layers require less time. So if it's a sculptural object like my skull here, I'm going to go with thinner layers and just sacrifice the time because I want those layers to not be very visible. I want there to be nice sculptural elements of the object. However, if I am printing something that's geometric or structural or practical, I'm not going to need that level of detail. I'm not going to really mind so much that I can see those visible layers. So I can go with thicker layers and save myself some time. So again, those are just all little tweaks that you can make during the design process. Okay, next we have shells. Shells are also known as perimeters, and they are the exterior walls of the print. So again, thicker walls means a much stronger structural object, but those thicker walls do require more time. If you go with thinner walls, sometimes your object might have a little bit of flex to it as well. And you might want an object that has a little bit of flex to it. So you would go with thinner walls. There's also flexible filament that's really interesting and to use too. And I'll make some filament recommendations here in just a bit. Okay, next we have the rafts. So what rafts are little helper support structures that help the 3D printed object adhere down to the print bed. So if you're taking a look on screen, if you can see where my cursor is dancing around here on screen, those little support structures on the corner of that box, those are rafts. Now, why would you use a raft? Well, you use a raft to help that object stick down to your print bed more securely. It helps with adhesion. So sometimes when you're printing 3D objects, there's not a lot of surface area to stick down to your bed. So as the printing process is going on, if there's not a lot of surface area to stick down to the bed, that object could come dislodged from the 3D printing bed. And then you've got a big mess on your hand because now the printing process isn't going to work and the object has broken loose from the bed. And now you've just had a failed print. Trust me, if you've been 3D printing for any length of time, or if you're new to 3D printing, you will experience failed prints. Happens all the time. But in my opinion, as a classroom teacher myself, those failed prints are always the best learning experience, because you can backwards engineer what went wrong. So it's great for troubleshooting. It's great for critical thinking. But sometimes there are some 3D printers out there that have sometimes leveling issues. The 3D printers that I'm going to recommend to you today all auto level. So that's one headache that you don't have to worry about. But sometimes 3D printers can be tricky with their leveling. And so rafts can sometimes help if you have a 3D printer that does have some leveling issues to help that 3D printed object stick down, adhere to the print bed better. Next, we have overhangs. So overhangs are those they are those 3D objects, or they are the components of a 3D object that hang out into space. So if you're looking at my skull here, it would be something like you see on this orbital bone, this jawbone here. Or on the example that you see there on screen, it would be the overhangs of that T that you see right there. Well, you need to remember that the printing process happens from the bottom up. So if you have overhangs, if you have structures that hang over about 60 to 70 degrees, you need support from underneath. Otherwise, your 3D printer can't just spit out filament and print into thin air. It's printing from the bottom up, so it needs to be supported. So if I was printing this T in this orientation, this orientation on the left side, I would need support over those 90-degree overhangs. Otherwise, those crosses on the T could never print into thin air. However, would you ever print a letter T in this orientation? I know that I wouldn't, because I could just flip it upside down and print that T upside down, and then I would need no supports. Supports are these scaffolding-like structures that are temporary, that are built to support structures from underneath that you peel away after the print is complete. So again, the orientation of your model on your print bed when you're working with the slicing software is important, because you want as little support structures needed as possible. But you can see here in the middle, supports are these removable scaffolding-like structures that provide support for any structures that overhang or seem to be hanging in midair of more than about 60 to 70 degrees. And so I'll show you what supports look like here in just a moment. Now, lastly, we have bridges. And what bridges are exactly what they say they are. They are the underside of the print that is supported at the ends, but not in the middle. And so typically, most 3D printers can print a bridge no longer than about 50 millimeters without support for underneath. So, if you have a long bridge, so if you have a long structure on your print that is supported on the sides, but not in the middle, you need to determine what the bridging tolerances are on your 3D printer. And there are great test prints that you can print to test out those tolerances. And I'll show you exactly what I mean by that.